Hello everyone, I am Rajatna Nanje from Sanjani College of Engineering. I am studying in TY BTech Mechatronics Engineering. I am here to present a presentation on the topic of speech to text using speech recognition, guided by Professor S.S. Kulkarni sir. Here is the content: Introduction, what is speech recognition, how it works, references and conclusion. Introduction. Nowadays, there are various software based on speech recognition to recognize the audio and to generate desired output. Maybe automating some tasks by taking users' voice command like Google Assistant, etc. In this presentation, we will understand how the audio signals are processed in speech recognition. What is speech recognition? Speech recognition is an interdisciplinary subfield of computer science and computational linguistics that develops a methodology and techniques that enables recognition and translation of spoken language into text by a computer with the main benefit of searchability. It is also known as automatic speech recognition, that is ASR. How the speech recognition works. Here we have a flow diagram which tells us how the process are happen on the input signal. The input signal we taken from the environment which is in analog form. Then digital conversion of that analog form takes place. Then time domain extraction and audio signal normalization. Then conversion of stereo signal to monochrome. Time domain to frequency domain conversion by using Fourier transform, and then frequency distribution using MFCC is done, and then we get a frequency domain distributed signal. First step, reading the file for audio signals. The first step in starting speech recognition algorithm is to create a system that can read file that contains audio with extension of .wav or .mp3 etc. and understanding the information present in the file. A recording is a file we give to algorithm as its input. The algorithm then works on the input to analyze its content and build a speech recognition model. Sampling. All the signals are recorded are stored in a digitalized manner. These digital signatures are hard for the software to work upon since machines only understand numeric input. Sampling is the technique used to convert these digital signals into discrete numerical form. Sampling is done at a certain frequency and it generates numeric signal. Choosing the frequency level depends on the human perception of sound. For instance, choosing a high frequency implies that the human perception of sound signal is continuous. Transforming audio frequencies. Frequency domain representation. To better understand an audio signal, it is necessary to look at it through a frequency domain. This representation of audio signal will give us detail about the presence of different frequencies in the signal. Fourier transform is a mathematical concept that can be used in the conversion of continuous signal from the digital time domain state to a frequency time domain state. Fourier transform is a mathematical concept that can decompose the signal and bring out individual frequencies. Step 3. Extracting feature from the speech. MER frequency septal coefficient, that is MFCC. MFCC is a technique designed to extract a feature from the audio signal. It is used the it uses the MER scale to divide our audio signal frequency band and then extract coefficient from each individual frequency bands, thus creating a separation between frequencies. MFCC uses a discrete cosine transform, that is DCT, to perform this operation. The MER scale is established on the human perception of sound. That is how the human brain processes the audio signal and different shades between the varied frequencies. Human voice sound perception. It is a human hearing capacity ranging from 85 Hz to 255 Hz. MEL scale. MEL is a pitch scale or a scale of audio signal with a varying pitch level that is judged by the human on the basis of equality in their distances. Recognizing spoken words. Speech recognition is the process of understanding human voice and transcribing into a text in the machine. There are several libraries available to process the speech to text, namely Bing Speech, Google Speech, Hundify, IBM Speech to Text, etc. We will be using the Google Speech library to convert speech to text. A few key features that a Google Speech API is capable of adapting of speech. This means that API understands the domain of speech. The API works with both on-prem or pre-recording file as well as live recording on the microphone in the present working environment. The speech recognition workflow explains the part after processing of signal where the API performs a task like semantic and syntactic correction, understanding the domain of sound, the spoken language, and finally creates the output by converting speech to text. Here are the references by which I have prepared this presentation. Conclusion: in this way, we understand how the speech recognition works and how it processes the audio signal and how different concepts and transforms are implemented on the audio signal taken from the nature to create a desired output. Thank you for listening. Thank you.